Alright, in this video I'm going to do just a bunch of examples of transformation on parent functions and give some explanation as I go to hopefully help you gain a deeper understanding. And on this worksheet I borrowed this from someone else, and I should have cleared the, you don't need to know the name of the parent function, so don't worry about filling that in if you're doing this worksheet, but you do need to know the equation of the parent function. For example, in number 1, this is y equals x squared is the equation of the parent function. And the graph, well, first of all, do the transformation. The transformation, we know there's a negative, a plus 3, and a minus 1. We know the negative is going to reflect across the x-axis because it's on the outside. The plus 3 is going to shift left 3, and the minus 1 is going to shift down 1. Okay, so the 3 is on the plus 3 is on the inside, so that's why it moves it horizontally. We know it moves to the left because there's that opposite effect when you're doing stuff on the inside. When you're adding or subtracting on the inside, it shifts it the opposite way of the sign of the shift. So if it's plus 3, it moves it to the left. If it's minus 3, it moves it to the right. And also remember, when you're stretching on the inside, if you're multiplying by 2, it's actually going to stretch it by a factor of 1/2. If you're multiplying by 1/2, it's going to stretch it. It's going to multiply, or it's going to stretch it by a factor of 2. So, so then finally, to graph this thing, I'm going to go to the. I'm going to just establish a new vertex, which would be to the left 1, 2, 3, and down 1. So I'm going to put a little dot right there. And then the negative, I know, flips it upside down. So then I'm just going to draw a normal parabola. We know a parabola normally goes over 1, up 1, over 2, 1, 2, 3, 4. So it looks something like that. Ooh, that's ugly. Let's see. 1, 2, 1, 2. Let's make this bigger so I can do it. There we go. 1, 2. We'll just do it right there. 2, 1, 2, 3, 4. And 4. And down, and down. So again, I'm getting these dots because it's just, I know that it's a regular shaped parabola. It hasn't been stretched at all. So I know normally a parabola, if you plug in 1, you get out 1. If you plug in 2, you get out 4. If you plug in 3, you get out 9, etc. So I can just put those, I can just draw a regular shaped parabola there. Okay, so that's the first one. Make sure you put little arrows on there. Number 2, that's the absolute value function. But again, I don't worry about the name so much. The parent function is y equals absolute value of x. The transformation, the negative is going to again reflect across x-axis, and the minus 1 is on the inside, so that's a shift right. So it's going to shift right 1. Again, if we were to draw that, I'm going to move everything to the right 1, which means the vertex moves to the right 1. And then it's a normal absolute value graph, except for it's upside down. So I'm just going to draw an upside down absolute value graph. There we go. And next one. So this is the square root function. So that would be the equation of the parent function is y equals the square root of x. And it looks like the only thing we're doing here is shifting right 2. Shift right 2. So that means that normally it would start right here. I'm going to go 1, 2, and then it's just a normal square root function, which means 1, 1 is in there. So I'm going over 1, up 1 from that first point, and over 1, 2, 3, 4, up 2, because we know that every y value is the square root of the x value, right? So it looks something like that. This is the y equals 1 over x parent function. And looks like there's 3 things going on. There's a reflection. So reflect across the x-axis. because it's on, we'll call it on the outside. You also can, there's a +6 on the inside, so that would be shift left 6. And there's a +2 on the outside, so that would be shift up 2. So now on this one, when I go to graph it, I'm going to graph the crossing of the asymptotes. So normally across the 0, 0. Now they're going to cross to the left 1, 2, 3, 4, 5, 6. And up 2. So that's going to be the asymptote crossing. So I'm going to draw the asymptotes because this graph is much easier to draw if you can see the asymptotes. And there's no stretch. It's only been reflected across the y-axis. So I know that normally from the asymptote crossing, if you go over one, up one, you'll hit the bow, kind of where the curve comes in. But that's been reflected down across the x-axis, so normally it'd be there, but now it's going to be down here. And also normally there'd be one here, which will reflect up to there. And then from there, I'm just going to kind of sketch it in. I know it looks something like this, making sure it looks like it's getting closer and closer and not parallel. Okay. Whoops, that just, I didn't mean to do that. Huh. C over 6. Fixed it. Okay, moving along. Oh, this is the y equals 1 over x squared. That's a fun one. And it looks like the only thing that's happening is the 2 on top and the -1 on the bottom. A lot of people have trouble with this. It might be helpful for you to think of it this way. Maybe that helps to see that it's just a multiplying by 2 on the outside. So that's going to be a vertical stretch by 2. And also a shift right 1. So then we go to graph it. Let's see, I'm going to go to the right one and again draw the asymptotes. So that would be to the right one, and that means we'd have an asymptote going right through there and an asymptote on the x-axis. Now normally from there I'd go over 1, up 1, but this is a vertical stretch, so I'm going to go over 1, up 2. So it'll be a dot right there. And normally I'd go over 2, up a half. I'm sorry. Normally I go over 2, up a fourth, but I'm going to go over 2, up a half. So that would be right about there. So now I know it's something like that. And of course it's an x squared on the bottom, so it's going to be the same thing over here. Whoops, I missed right there. Something like that. Okay. Make this small again. This is y equals cube root of x. And looks like there's just 2 shifts happening. So shift right 2 and shift down 1 because of the negative. So then this is a cubic, so I'm just going to move the thing I'm moving from the origin is that one little point that it's completely vertical. So I'm going to go to the left. Whoops! Oh man, that was close. I should have been shift left 2. Thanks for catching that. Because that's a +2, so I should be shifting to the left. Yep. So left shift to the left 2 and down 1. So that right there is where the vertical point is. And from there, make this a little bit bigger. Go over 1, up 1. So right there, over 1, down 1. So it's going to look something like that. Okay, so that's the graphing and going from the equation to the transformations and so forth. This next one gives you an equation, it's the same idea, but we don't have to graph it. Yeah, so this one, we're also talking about domain range, so that's kind of a good thing. With the transformation, this is just a shift right 1. The domain of a square root function is usually from 0 to 1, but this shifts everything to the right. So it's going to go from 1 to infinity. And the range it's still going to go from 0 to infinity because we didn't shift it up at all. Okay, this is a parabola that's been shifted up 1 and reflected across the x-axis. So reflect x-axis and shift up 1. And the domain, so if you think about parabola, normally it's sitting like this. It's been moved up 1 and shifted down, so it's looking like this now. So the domain is still going to be all real numbers, so from negative infinity to infinity. But the range is going to be from negative infinity up to the highest point it will be is 1. And we will include 1. And number 7 is an upside down absolute value function. So that would be, because it's reflected across x-axis and it's shifted to the right 2. So the domain, so if you think about that, if you try to visualize that, that's going to be looking kind of like that, right? So the domain is still going to be all real numbers from negative infinity to infinity, but the range is going to be from negative infinity to 0. It will not go above 0 because the absolute value is making everything positive, and then the negative on the outside makes it negative again. Okay, so this is this has got a couple things going on. It's got a shift to the right, to the left, man, I almost did it again, to the left 2, and shift down 4. So again, this is, you guys know what this looks like, right? It's I call it the volcano function because it looks like a volcano. But if you move to the left 2 and down 4, so it's going to look something like that. So we know the bottom of it is at negative 4. So I'm talking about range now. I skipped the domain. I'll come back to it. So the bottom, the lowest it'll go would be 4. Oh, and I don't want to include 4 because that's an asymptote, right? So that'd be negative 4, but it will go up to infinity. The domain, however, is going to go from negative infinity, but it will skip at, whoops, I'm putting that in the wrong spot, aren't I? Should have been negative 4 there and infinity there. Okay. The domain is going to be almost all real numbers, except for you'll be missing negative 2. So we do it like this. And then finally h, negative on the outside, so that reflects across x-axis. And the plus 9 is going to shift left 9. And so it's just a normal parabola that's been turned upside down, hasn't been moved up or down at all, so the range is going to go from negative infinity to 0. The domain, of course, is just going to be all real numbers from negative infinity because it's a parabola. Okay, the parent function description of the transformation, right? Okay, so this is one. I think there's a specific request about some more of these, so this is good. Give the parent function a description of the transformation. So we got the absolute value, so that's y equals absolute value of x. And it's a vertical shift up 5 and horizontal shift right 3. So it's just 2 shifts. So I'm going to go y equals, put the horizontal shift inside. So that would be a shift right. So we want to do minus 3. And the vertical shift on the outside, and it's up, so we do plus 5. Number 11 says the square root function, so we want to go y equals the square root of something. Reflection over the x-axis, so that's a negative on the outside. Horizontal shift left 2, so that's got to be on the inside, but it'd be a plus 2. Number 12, a cubic, so I know right away to go y equals something cubed. Reflection over the x-axis, so once again that's a negative on the outside. Horizontal shift left 8, so that'd be x plus 8. And vertical translation down, translation is another word for shift. Down 3, so that'd be minus 3. Oh, and that's all of them. So that's that worksheet. I think I'll pull up, do a few more of those from description to equation that are maybe a little bit more complicated. So let's take a look at one. Let's say that you have y equals 1 over x squared. And you want to stretch vertically by 2 and shift up 5 and shift left 2. So my parent function is y equals 1 over something, and that something has to be squared, right? So the stretch vertical by 2, I want to multiply on the outside. So I could just replace that 1 with the 2, because that would be like, because we know that 2 times 1 over something is going to be 2 over something, right? So we could just do that. That'll take care of that. Shift up 5, that needs a plus 5 on the outside. And shift left 2, that would be x plus 2. Right? Here's another example. Let's say y equals x squared, and we want to stretch horizontally by 2 and shift right 4 and shift up 5. So write an equation for that. So once again, I'm going to go y equals something squared. Now if it's stretching horizontally, that means I got to multiply on the inside. And since I'm stretching horizontally by a factor 2, that means I'm going to multiply by 1/2 on the inside, because that reciprocal effect. And since there's a shift on the inside also, I'm going to do kind of some double parentheses here, because I want to factor out the shift, the stretch factor. So that 1/2 is going to go on the outside, and then I'll have x minus 4 in there. So notice that everything's on the inside still. Everything's inside the squared. The 1/2 is inside the squared, and the minus 4 is inside the squared. But I've written it with the stretch factor factored out of the shift. And then finally you could shift up 5, so that'd be plus 5. Now if you want to, of course, you could write this as 1/2 x minus 2 squared. That's the same thing, obviously. But this is the easiest way to see all the effects of that. Okay? All right, so I think I'll just, closing in on 20 minutes here, I think I'll close the video now. Hopefully this has filled out some holes in your understanding of the transformations and parent functions.